Hello, Team 5th grade. It's your self-proclaimed favorite mathematics teacher, Miss Aaliyah Brewster. It's time for us to do grade 5 mathematics, but just in case you're not feeling motivated, remember the words of Paul Halmos. The only way to learn mathematics is to do mathematics. So what are you waiting for? Grab a pencil and a notebook, get settled, because we're about to start. Are you ready? Let's begin. Today we're going to be reciting the 16 times table, and then we're going to discuss how we can multiply two-digit numbers by a one-digit number using 3 approaches. But first and foremost, let's recite the 16 times table. Feel free to join in with me. Let's go. 16 times 1 is 16. 16 times 2 is 32. 16 times 3 is 48. 16 times 4 is 64. 16 times 5 is 80. 16 times 6 is 96. 16 times 7 is 112. 16 times 8 is 128. 16 times 9 is 144. 16 times 10 is 160. 16 times 11 is 176. And 16 times 12 is 192. Thank you for reciting the 16 times table with me. Now let's move on to discussing the first approach that will help us when we're multiplying a two-digit number by a one-digit number. The first approach is called the traditional approach, and to do this, we begin by multiplying from the ones column, and if the product of that multiplication is a double-digit number, we write the face value of the ones at the bottom, and then we write the face value of the tens at the top in the tens column. And finally, we multiply the tens place number and add the extra from before. Let's work a practical example so that you can better understand the traditional approach. For example, if we were asked, what is the product of 16 and 5? We know that product means multiply. Note well. So, we multiply 16 by 5. To do this, we set it up. 16 at the top, 5 at the bottom. And for the 16, we have the 1 in the tens column and the 6 in the ones column. And we write the 5 beneath the 6 in the ones column. And then we begin to multiply. We start by multiplying 5 times 6, which would give us 30. And 30, of course, is a double-digit number. So we write the 0 at the bottom under the 5, and we put the 3 at the top in the tens column. And then we multiply. 5 times 1 would give us 5, but we're not finished there. We have to remember the 3 that was written at the top. So we add 5 plus 3, and that would give us 8. Therefore, the product of 16 and 5 would be 80. Now that is the traditional way of doing it. Okay, boys and girls, now that we're finished discussing the traditional approach, let's move on to the open array method. This method is quite simple and I know you're going to enjoy it. To begin, we first expand the double-digit number according to its place value. Then we multiply the place values individually. And lastly, we add the product of both numbers. Let's do a practical example so that you can better understand the open array method. For this example, we'll be looking at the question, what is 16 times 7? What is 16 times 7? According to the open array method, we begin by first expanding the double-digit number according to its place value. In this case, the double-digit number would be 16. And when we expand that number according to its place values, we know that the 1 is occupying the 10th place value. Therefore, we write that as 10. And we know that the 6 is occupying the 1's place value. Therefore, we write that as 6. Therefore, the expanded form for 16 would be 10 plus 6. Okay, The second step is to multiply the place values individually. So what we do, we multiply 7 times 10, and then we multiply 7 times 6. First, 7 times 10 would give us 70, and 7 times 6 would give us 42. We know now that our products are 70 and 42. We add those two products together, and that would give us the total of 112. Therefore, 16 times 7 is equivalent to 112. That, boys and girls, is how we work the open array method. Now, boys and girls, let's move on to our third and final method, which is the repeated addition approach. We begin the repeated addition approach by first organizing the multiplication problem to facilitate addition. And then we start by adding from the ones column. And if that answer or the sum of that give us a double-digit number, then we write the value of the 1 at the bottom, and we write the value that's in the tens place value above the 10 column. And then, of course, we add the tens column, and that would give us our answer. Let's work a practical example. In this case, we're asked to solve 16 multiplied by 3. 16 multiplied by 3. Using the repeated addition approach, when we're asked to multiply a double-digit number by a single-digit number, we have to look at the single-digit number, and that would indicate how many times we're adding the double-digit number. In this case, it is 3. So we're adding 16 3 times. Okay? So we set up the problem to facilitate addition by putting 16 plus 16 plus 16. And here we have all the 6's in the ones column and all the 1's in the tens column. So now it's perfectly set up for us to do our adding. So we begin by adding 6 plus 6 plus 6, which would give us 18. Of course, 18 is a double-digit number, and we cannot write 18 at the bottom whole as it is. So what we do, we write the value of the number in the ones place value column, which would be 8. So we write that just below the 6, and then we take the 1 and we put it over in the tens column. Therefore, our answer there would just be 8 at the bottom. Moving on to adding the tens column, we add 1 plus 1 plus 1, remembering also the 1 that is at the top. So we're adding 1 4 times, and that would give us 4. Therefore, our answer for 16 times 3 would be 48. It's that simple. That has brought us to the end of yet another lesson, boys and girls. I trust that you would have enjoyed all that we discussed. Remember, we recited the 16 times table, and then we looked at various approaches to help us when we're multiplying a 2-digit number by a 1-digit number, which is the traditional approach, the open array method, and the repeated addition approach. Okay, remember the words of Paul Hamels, the only way to learn mathematics is to do mathematics. So this means that even though our study time would have come to an end, that does not mean that you have to stop practicing. Thank you once again for tuning in, and goodbye.